We're recording. Welcome to Calculus in the PN. I'm your host, Harambe. Now, I had mentioned when we did this, guys, remember how I said something about when you solve this, you actually wouldn't have, this would be like absolute value and so on? And then I said, but that's not the focus, and it isn't the focus here, but afterwards I'm like, I don't like leaving details out. So really what it is what's the domain and range of the function as given? What's the domain of this function? You can't have a negative under a root sign, so what's the domain here? 3 and up. Right. Yeah. So the domain is, I'm going to use, you want to do it this way? Can be greater than or equal to 3. Okay. What about then what does that mean, the range? What's the smallest number in the range? 0. Okay, so x is going to be greater than 0. And could it be equal? Yeah. What do you know then? Right here we have the inverse, right? What's the domain of the inverse? Ah, yeah, the range becomes the domain. Okay. And that takes care of it as far as, why am I putting that range first? Anyways, actually it won't fit here. I'm going to just, got the wrong thing there. Okay, so the domain, boom. Why did I noticed I made an error there before. And the range, in this case, is y. What's my error that I made in my domain range before? X, yeah. Okay. I'm using y for those values. Okay. As long as you do this, then this keeps everything straight and stuff like that. It doesn't affect the algebra that you did afterwards. But I don't know. Like I said, I told you not to worry about it. And it wasn't the focus of it, but it just didn't sit well with me. But I did do 2 examples with you and asked you to try the first 2 questions. Now, people who stuck around number 5, for example, I'm not going to go over right now. They had the right answer, and number 5 was just manipulated a little more. So I'm not going to be too worried whether you can manipulate to the exact same answer. Just apply these formulas, and we'll see, like, within reason. Okay, let's just see here then how these formulas work a little more, and then we'll move on to a little something. Oh yeah, the secant negative 1, 3x minus 4. Secant. The arc secant, or the inverse of secant, when you do the derivative of an expression like this, take the derivative of the inside, then absolute values of the inside, then the inside squared minus 1. It's that easy. Like, so this will be, I'm going to just move it so I can still see this. dy by dx is equal to u prime on the numerator, so 3, because 3x minus 4. And then u in absolute value, that's not negotiable right now. We're just putting that, you need that absolute value. And then u squared minus 1 inside. So 3x minus 4. Super simple. We can just leave it like that, right? You guys good with this? So you see how I just applied the formula there? Blah, blah, blah. Okay. Now you guys have paper. Once I scroll this down, you can't see the rules. But you'll refer to them, and I'll refer to them on my paper here. Yeah. Okay, let's look at this one here. We'll do implicit differentiation all the way across this. The left side seems pretty easy now. A whole. So doing implicit differentiation for this expression here. First part of the expression becomes x becomes 1 plus dy by dx. One group of dy by dx. Equals. Now, the tan negative 1, the inverse of tan. The derivative is, I see u prime on the top. They all have u prime on the top, don't they? Okay, and then u squared plus 1 underneath. I'm going to do the easy part, the u squared, x squared plus 3y squared plus 1 underneath. Okay. The top, though, it's not that hard either. Oh. What do we have here for a derivative?
2x plus 3 times dy over dx.
Exactly. 2x plus 3 dy by dx. We're supposed to solve this for dy by dx. This isn't that far off from I think the second implicit differentiation question you have. You have a dy by dx on one side and the other. I would say get rid of your fraction first. So, I'm going to multiply both sides by this expression, right? So, yanking that up there. I'm just thinking here, how do we want to do this? Do you guys, should I show lots of steps or just kind of? Okay, I was hoping you'd say just skip. X squared plus 3y squared plus 1. That's from the denominator there. Times 1 plus dy by dx. 2x plus 3. Okay? We're all good with this, right? This means I now have to distribute, but I'm not going to multiply this big meaning here out here. I'm going to leave it like this. And I'm going to just say, well, times 1, it's this repeated. I'm not going to really, I'm just going to list it beside dy by dx, though, right? I'm not going to multiply anything out. So really, I just rewrite this twice in a sense, right? Okay. So then, that becomes x squared plus 3y squared plus 1. So that's the times 1. And then plus, I'm going to rewrite that expression. I'll keep this one in square brackets, though. X squared plus 3y squared plus 1 dy by dx. 2x plus 3 dy by dx. Okay. That's what I was trying to do in one step earlier, but you guys said show lots of steps. It's your funeral. Take you forever. Okay. Now, I'm going to move this by subtracting onto the other side. And I'm going to move these to that side by subtracting 1 and subtracting the x squared, so on, right? So, it's going to be a big old mess, but I get the big expression. I still have my x squared plus 3y squared plus 1 glued to dy by dx. That's the factor there. And now I also have minus 3 dy by dx equals 2x on the left, or the right still, but I'm subtracting the other stuff. Minus. I'll pause for a second. Yeah, where did I make a mistake?
You put the exponent 2 next to the 3y, and it should be outside the bracket.
You're right. See? I knew I made a mistake. I'm careless when I'm talking. Thank you much. Okay. On the left, what do we do?
Take the dy by dx.
Yeah, we have a common factor of dy by dx. I could write the next step with this expression without this here and just put it in front. Dy by dx. But I'm not going to, because I think you guys see what's left behind is, well, it's dissolving now, but you can see that. Basically, I'm going to keep the expression on the right as is. There's no easy like terms to group together. And I'm just going to divide by this part after you've removed the dy by dx, okay? So, dy by dx equals 2x minus, I'll be careful where I put my exponents now. After Tristan tuned me in. Yep. Plus 1 minus 3. I could group the 1 and 3 together, but I mean, that's about it. Ain't that so? I think so. Okay. I'm not suggesting you simplify much more than that. Okay? You get the idea there? These formulas, apply them. Really not really doing a lot of calculus, like, because it's just a formula and you're applying it. Like I said though, in a month or two, you won't have these formulas in April, whatever. You should be able to do these by first principles too. Meaning, without this formula, the first thing I would do is, I don't like remembering formulas, that's me. I'd rewrite this as the tan of, and then the x plus y inside there, and rewrite the inverse as tan of x plus y equals x squared plus 3y. And work it out from first principles there. But, take a look at this last thing. Inverses. I've given you a table of values. I just made it up. Now, this is, without knowing what the function is, a bunch of the values. First of all, let's just take a look at these values here. Okay. The first two columns, you guys understand? This is something you could give a grade 9 student, grade 10 student. They should understand this, right? The x you put into the function, you get out a 2, you get out a 4, etc. It doesn't matter what the function is, whether it's x squared minus 8 or something like that, who knows? But that's not the point. But do you guys get that? First of all. And then, if you evaluated the derivative with these given x values in here, that's the corresponding values, right? Now let's think this through, because we want to find the derivative of the inverse evaluated at -2. You guys get that? Uh-huh. Well, from a table of values without the function, it can be done. First thing is without flipping to the first page, because there's the formula there. By definition, an inverse. If you put an inverse inside the function itself, what does it come out to give you always? X. So if you get this, because I'm preparing you right now, you can memorize it and stuff like that, but in 2 or 3 months, as long as you know what an inverse is, the first thing you should write out is f of the inverse plugged in is equal to x. If you put the inverse inside the function, it undoes everything, right? And you just end up with whatever number you plugged into it. Right? That's what this tells you. Then we want the derivative of the inverse expression. So let's just apply the chain rule, do the derivative of what we have here, right? So we do the derivative of the outside, f prime, of, leave the inside alone, Then do the derivative of the inside. F inverse's derivative, I'll notate as such, equals 1. And then it's easy to solve for this. One over the derivative with the inverse plugged inside it. If you want to, you can memorize that, but I'm telling you, there's a lot of things you can memorize, and this doesn't have to be memorized. Honestly, if you just do this a few times in April when you're getting ready for the test, you'll be fine. I've never had, last year's students didn't find it very confusing. And there will be other things you can spend your brain on instead of this. Anyhow, according to this, I should be able to evaluate this chart here we're using. I want the value of the inverse's derivative at -2. So essentially what I want is, well, f inverse at 2, its derivative, and I'll move that down because it's running into it, is equal to 1 over f prime all I've done is just replace x with 2, right? So far I haven't done anything, have I? But does that make sense what I just did? Now what does this mean? And how am I going to use this table of values to help me do this? Ding dong. I don't know. Yeah?
Can, switch?
Switch.
Isn't it supposed to be negative? Yeah, that's what I was in.
Oh, it's -2. Thanks. I just made a different value. Yep.
Good option.
I could have done 2 as well, actually. Different answer. But I asked for -2. Thank you. Sorry. Switcheroo somehow. Let's just sort this out. You know, here's the regular notation, right? Underneath, let's just do some reversals. If this, considering these 2 columns here, the first 2, the inverse, is it the first or the second column that is like the x values for the inverse? Second column. Everything's reversed on the inverse. X becomes y, y becomes x. So underneath this, I usually advise people to, if you get a chart, and there's a very strong chance you're going to get a question like this on an AP test. You're going to say, well, for the inverse, these are my x values above there, right? And these are like my y values, so these are my inverse values. Making some sense? Yeah? Okay. Then what? Is that still the same derivative values then? Or who cares? Who cares? Okay. He said, who cares? What do I need to evaluate this? First, I need to put this in, right? So for the inverse, when I plug in -2, what do I get? So for the inverse, I'm looking like this is the plug-in value. When I plug in -2, what do I get? 0. Inverse functions work backwards, right? Y becomes x. Left becomes right. Drunk becomes sober. All these things. I'm just thinking of this presentation I just was having. Anyways. So, 1 over f prime. -2 corresponds to 0 when you're doing inverse. Okay. And then, we didn't need to do anything with that f prime column because what's the f, the derivative, evaluated at 0? Yeah. It actually happens that you start here, you go to there, and then you say, well, -1 happens to be the value, right? So, 1 over negative 1. I'll even write it out with 2 steps. Not that I'd advise it. Negative 1. Huh? Yeah? Yep. If I hadn't made, I made a mistake initially and I used positive 2 here instead of, this plus sign here. Can you just quickly tell me how that would have worked? Positive 2 would have corresponded to, which the evaluated would have been 8. You could see there, right? With this set of values, could I have done inverse of 3? No, we have an x equals 3 for the regular function, but nothing in the, when you look at it from the inverse's perspective, you couldn't do 3 with this set of values, right? So if you're given a set of values, that's how you go. If you're given a graph, you can think of it as a set of values, and remember the x's become the y's, etc., right? It's not too much different. So, yeah, I'm all ears.
If you're given a graph, do you recommend turning it into a set of values, or do you just recommend drawing the inverse?
It depends on the question. Some I would, you can, if you're given a graph, y equals x is the mirror line, right? Because y equals x is its own inverse, right?
Whoa.
But do you guys follow what I'm saying? When you reverse the y and the x and y equals x, it's still y equals x, right? So 2 comma 2, the inverse is 2 comma 2.
No.
Anyways, that's your mirror line. You guys remember this slightly, because I went over it a little bit in September. Okay. So sometimes drawing the graph is helpful. Sometimes, though, literally taking 1 comma 2 and making it 2 comma 1 is helpful. Depends on the nature of the question. Now, those are a lot of questions. I gotta just see if I can narrow this down a bit. Did anyone get past 5 yesterday? Okay, so nobody will be heartbroken if they spent all their time doing, and I scratched some things. I'm just thinking so 1 and 5 are definitely worthwhile. They're all worthwhile, but 5, 6. I like them all, but can't do them all. One, 5, 7. Let me see about 12. Yeah, 12 is good to do. I have the answer there too. It's 1. That one's good to do. 14's good to do. Actually, these aren't as bad as I thought they'd be.
Will we eventually have to memorize the derivative equations for trigonometry?
For the inverses, I'd say no. It's not worth your time. But for the 6 trig functions, yes. Like those ones on the board.
Yeah.
It's not worth your time. If you even spent any time, it would just be sine and cosine are the only ones that tend to be paying off. Actually, you know what? Looked it over. It isn't that bad there. So. Okay. Don't be shy. Give these a try.
When you rhyme like that,
You have to. You must. Don't get loud.